Welcome to Chemistry Basic Videos. Today we are going to discuss about three things: solubility, solubility product and the common ion effect. Now first we'll start with what is solubility of a substance. Well, if we want to define what is solubility, I'll explain to you. Let us take three flasks A, B and C. Fill it with 1 liter of water. 1 liter of water, okay? And then take a substance X, dissolve it in A. Suppose 25 grams dissolves, absolutely dissolves. In this 26 grams dissolves. In this 27 grams does not dissolve. It means 26 grams is the last amount of the substance dissolving in 1 liter of water. So here this is a saturated solution. This is saturated solution in flask B. Now look here, how solubility is defined as? It is defined as concentration of a substance in its saturated solution. If you don't mention the word saturated solution, even this 25 grams also will become the solubility. So the concentration over here is 25 grams per liter. Here it is 26 grams per liter. So the solubility of the substance is 26 grams per liter. So let us define as, it is the concentration of a substance in its saturated solution. If you don't mention the word saturated, it means then even 25 grams per liter also will become solubility. So we have to say concentration of a substance in its saturated solution. It is very important. Now, some will say that, okay, I'll dissolve 27 grams also. He starts heating it, the flask C, and 27 grams also gets dissolved. So now he'll say, see here, so this is the saturated solution of 27 grams. So I'll say that, okay, I'll correct my definition. Solubility of a substance is concentration of a substance in its saturated solution at a given temperature. This 26 grams is at room temperature and 27 grams is, say, about 50 degrees centigrade. So see, for solubility, you'll have to remember three things. Number one, concentration. 2, in its saturated solution. And 3, at a given temperature. It is very important. So see, in the numerical problems, whenever they are giving solubility, they write the temperature at 25 degrees centigrade or room temperature. So it is very important. Last point again I'll repeat. It is the concentration of a substance in its saturated solution at a given temperature. This is solubility. It is a constant and it is represented by S. This is solubility. So now we'll discuss what is solubility product. This is also a constant and written as KSP. Now solubility product is for very less soluble substance like AgCl or silver carbonate. It is called a sparingly soluble salt, very less soluble. The opposite of sparingly soluble is readily soluble. So silver carbonate is a sparingly soluble salt and we are going to discuss what is the solubility product of it. Now silver carbonate, suppose in a flask you have taken 1 liter of water and you have added, say, about 100 grams of Ag2CO3. Because it is sparingly soluble, only 0.1 gram will dissolve. When the substance dissolves, it is in this ionized form, Ag and CO3, 2 negative charge. This is the soluble part, this is the insoluble part. So this is 0.1 gram and this is 99.9 grams. So the solution is saturated. Now let us apply the law of mass action for this. So we'll get K is equal to concentration of silver ions dissolved raised to the square into concentration of carbonate ions divided by undissolved or undissociated silver carbonate. We write it by S, solid form. We said just now that this is sparingly soluble, very less soluble, only 0.1 gram dissolved, so 99.9 gram remains undissolved. So we can say 99.9 approximately is equal to 100. So this is constant, so we will get K is equal to concentration of silver ion square into concentration of carbonates ion divided by constant. Why constant? Because this is 99.9. Earlier I took 100, so both approximately is equal to same. So this is constant. So K multiplied by a constant is equal to a new constant KSP, which is equal to silver ion concentration into carbonate ion concentration square. So see, let us define now. Solubility product KSP is a constant. It is defined as product of concentration of ions raised to the respective power in a saturated solution at a given temperature. 4 points. Look here, see. 1. Product of concentration of ions. Second, in saturated solution at a given temperature. Of course, here raised to the respective power, it is understood. So see, 3 major points. How it is that? Solubility product is a constant. It is defined as product of concentration of ions raised to the respective power in a saturated solution at a given temperature. Now, we'll discuss what is common ion effect. It is understood by the word common ion means there are 2 substances and one of the ions is common over here. Now let us take H2S. It is a weak electrolyte. It dissociates in a solution as 2H plus and S minus minus. The weak electrolyte, say it dissociates to 5%. So this is 5 and this is 95% weak electrolyte. Apply the law of mass action over here. We'll get K is equal to H plus ion concentration square to the sulfide ion concentration divided by H2S. This is equilibrium constant. Now, to this weak electrolyte, I will be adding a strong electrolyte containing the common ions H. I am adding a strong electrolyte which dissociates to a greater extent containing the common ion H, so that HCl will dissociate as H plus and Cl minus. Strong electrolyte, 95% dissociation. So what will happen due to the addition of this strong electrolyte containing the common ions? Suddenly the concentration in this equation of H plus will increase. There's a danger that K will change. K is equilibrium constant. It won't change so easily. It will adjust itself in such a way that it remains constant. For example, we have 4 is equal to 4 into 2 upon 2. 4 is equal to 4 into 2 upon 2. Now what you do is you increase this 4 to 8. So this will change. So if we want to remain this 4 as constant, we should increase this to 4. So because H plus has increased, K won't change so easily. It is an equilibrium constant. So what it will try to do, increase the concentration of H2S. How? By backward shifting of the equilibrium. Earlier it was 5%, now it will become 2%, and this will become 98%. By this way, K will try to adjust itself. So see, what is common eye effect? First point, if to a weak electrolyte means dissociation 5%, 7%, 8%. A strong electrolyte containing the common ion is added, then the dissociation of that weak electrolyte is further suppressed. This effect is called as common ion effect. Again I repeat, if to a weak electrolyte a strong electrolyte containing the common ion effect is added, then the dissociation of that weak electrolyte is further suppressed. This effect is called as common ion effect. So what were the 4 points? 1. If to a weak electrolyte. Second, a strong electrolyte is added containing the common ions. Now this is a very, very important, common ions. Then the dissociation of that weak electrolyte is further suppressed. This effect is known as common ion effect. If to a weak electrolyte, a strong electrolyte containing the common ion is added, then the dissociation of that weak electrolyte from 5% to fall to 2%, further suppressed. This is called as common ion effect.